Okay, you're welcome to my space. Um, my name is Nathaniel Nanley. I'm a protocol engineer, and I want to take you through a very simple workshop, a blockchain CLI tool, a simple command line blockchain implementation in Rust. So basically, what we'll be seeing an overview of this workshop is we're going to see certain fundamental concepts of the blockchain and features in memory blockchain implementation, modular and scalable Rust projects, and we're literally going to be interacting with our codes because it's the CLI. Now, the features we're going to be exploring in this workshop is Genesis block. We're literally going to see how Genesis block are initialized on the blockchain, and we're going to see the functions responsible anytime we want to add a block on the blockchain network, and we're going to have a function that helps us view the list of all the blocks that were added on the blockchain network, and we're going to see data integrity, ensure valid hash preference. It's a security measure that is used in the blockchain. Now this is for my Rust dev. So this basically is my project structure. I have a main.rs file, the lib.rs file. I have a blockchain folder, the CLI, the utils, and the test. So basically, based on this project here, based on this workshop, we're going to evolve around or within the blockchain folder, because most of the things we'll be talking about will be within this folder. Yeah, so the dependency we'll be using for this workshop and the project we'll be exploring is the chrono that helps me get the current timestamp, and the SHA-2 that helps me generate the hash. So without any further ado, let's see the code and let's see more of it. Okay, all right, so like I said earlier on, we're just going to be exploring the blockchain folder, the block.rs file, and the chain.rs file. So the first thing I did here is I call my chrono library that helps me get the current timestamp, and the SHA-2 that helps me generate a hash. Now the first thing I did in this code is that I created a struct that helps me get a template of the blocks I want to see in my blockchain. So the blocks that I want to see, the nature of the kind of block I want to see is that it should have its index and the timestamp, the data, the previous hash, and the hash. So basically this is now telling you that how we want to use this block is that we can only store data as strings on our blocks. So the first thing I want to do within the block.rs file is that I'm trying to create a new block. Now in creating a new block, which is this new function here, it takes in the index, the data, and the previous hash. But based on this struct here, the templates of the blocks that we are creating must have timestamp and hash, but my function here does not have timestamp and hash. So what we need to do is that we need to create a timestamp and a hash. For our timestamp, that's when we use the chrono, which is the UTC library that we're getting from Rust. So I get the current timestamp with which this block was created, and then for the hash, I created a function that helps me calculate the hash of the block. Now this is the function here. Now this function takes in the index, the timestamp, the data, and the previous hash, and then calculates the hash for me, and then I store it in this variable. After getting all of this, I return a block template of index, timestamp, data, previous hash, and the hash. So basically what this file, the block.rs, does is that it creates a new block for me. Every time you want to create a new block, these are the functions that you call. Like literally every time you want to create a new block on the blockchain network, this is actually the functions you are calling. Now for the chain.rs file, what I did here is that I call the block.rs file inside, because I need to use the new function within this file. So the first thing I did is that I have a struct that has a variable inside of it taking a record of all the blocks that we are creating. So every block that is generated, every block that is created and to be added in the blockchain network is stored in the blockchain, is stored in this blocks variable. So the first thing I'm doing here within this file is that I'm trying to create the Genesis block. So like any other block, we need to call the new function, and this new function takes in index, data, and the previous hash. So it takes in the index. For my Genesis block, the index is 0, and the data, I just stored it as Genesis block. It can be anything. It can be anything. And the previous hash, which is 0. Like I said earlier on, Genesis blocks, the previous hash on the Genesis blocks are always 0. So what I did is that I updated this vector. This, you can call it, you can see it as an array, the vector of all the blocks that we are creating. So basically, after this line of code, the block that is available in my blocks variable, in my blocks vector, is basically the Genesis block alone. So the next function here is the add block function. This add blocks function is actually taking in data from my user, from the user, to store it on the blockchain. So every time data are stored, a new block is created so that that data can be stored on the blockchain network. So what you are doing basically is that for that data to be stored, a block must be created, a template must be created, and we've seen the template from our block.rs file. This is the template: the index, timestamp, data, previous hash, and the hash. So we want to add a new block on the blockchain network. So what we need to do is that we get the instance of the previous block that was initially added on the blockchain network, but for our states here, the previous block that's already added on the blockchain network is our Genesis block. So when we are trying to get the last block, what we are trying to fetch, the data we are fetching is, we are fetching data from the Genesis block. So we're trying to create a new block here, calling the new function from our block.rs file, and then the index here. So basically the index of this new block we are creating will be an addition of the index of the previous block, and then we have the data of the block we are trying to the block we are trying to create, and then the previous hash, which is a copy of the hash that is on the previous block. And then what we did now here is that we added this new block we've created to the array, to the vector of all the blocks that were created. And now we also have a function that returns the list of all the blocks that we have created. If we want to see the list of all the blocks created, we call the get blocks, and it will return the list of all the blocks that we have created. So without further saying, let's see how these things work in a simple demo. So running this like a CLI, like I said from the introduction, this is a CLI that helps us interact with our code. Now this is add block, this is view blockchain, and this is to exit the process. If we want to add a new block, we type 1, we take in the 1 input. So it says enter data for the new block. So what do we want to store on the blockchain? Let's say we want to store the word protocol. We want to store the word protocol. Block added. So what is now happening is this: when you want to store a data on the blockchain, these basically are the functions you are calling. This is actually the function you are calling. We've literally stored a strings protocol on the blockchain network, and this is the function we are calling. So let's view the list of all the blocks that were created on the blockchain network. Let's see. Now we have, this is the first block that was created on the blockchain network with the index of 0, the timestamp, the data like we've stored, Genesis block, the previous hash, which is 0, and the current hash of the Genesis block, which is this. Now you'll notice that the previous hash is actually the hash of the Genesis block. This is for security sake. And then the hash of the block we've added. Now this is the data we've stored on the blockchain. We can add another data on the blockchain. You can add another data. This time around, let me add these strings, Ethereum, and let's view the data. Now you can see the list of all the blocks that were added. Now basically this is how these things are happening. You're literally seeing the code responsible for adding new blocks on the blockchain network. Anytime you want to store data on the blockchain network, these basically are the functions that you are calling. This is basically the code you are playing around with. It's amazing to see how these things are working in a code level. It helps us as protocol engineers. So without any further explanation, I think I'll call this the end of the workshop. If you have any question in regarding this little workshop, you can reach out to me. This is my Twitter handle, nanlenata92210. If you have any project you want to run in regarding the workshop we've done, you can reach out to me as well, and then we'll see how it works. Yeah, so see you in the next workshop. Just a little teaser, we'll be talking about the EVM and how opcodes compile, how smart contracts are compiled to opcodes, and we'll see all of these things in detail. So see you in the next workshop.